everyone. I welcome you once again to another session of Exploit Tutorial. Exploit Tutorial Learning Made Easy. So, my name is Sir Thomas once again, and today we'll be analyzing another problem on resolving forces into two components. Example 2. So with this particular problem which has been given to us here to analyze, now we have this particular figure which has a 50-pound force inclined to the y component or to the y-axis at an angle of 50 degrees. We also have our 40-pound force and we have our 60-pound force. Now the question says, determine the magnitude and direction of the force system. We have to determine the magnitude and the direction of this particular force system. These force systems are concurrent forces. That means they pass through a common point. Now, analyzing this problem, we quickly have to redraw this our particular figure on the XY plane once again to have a clear view of what we want to analyze. So we have our X, Y, and the X. We have our 60-pound force here, making an angle of 25 degrees with the X. We have our 40-pound force here, making an angle of 60 degrees with the X. And finally, we have our 50-pound force here, making an angle of 50 degrees with the negative y-axis. Now, we have to find for the what? For the total sum of x component of the force and the total sum of y components of these forces. So, sum of x components. Sum of x components. So whenever we pick a particular force, we resolve it to the x component we put here. So let's start from the 60-pound force. So we have 60 cos 25 degrees. Why cos? Because 25 degrees is adjacent to the x axis. Thank you. Now let's move on to the 40-pound force. So we have plus 40 cos 60 degrees. Why cos? Because 60 is adjacent to the x-axis. Then finally, we have negative 50 sine 50 degrees. Why negative? Because if you are to resolve this 50-pound force into the x component, it will lie on the negative x-axis. And here, the angle is rather adjacent to the y and not the x. That's why it took sine. Please, I hope you are clear with that. Good. Now, summing all these forces together, we will have 36.076 Newton. 36.076 Newton. Let's proceed to the summation of forces in the y component. So summing forces in the y component. So we have our 60-pound force, which is 60 sine 25 degrees. Then we have our 40-pound force. Now when we resolve the 40-pound force, it will lie on the negative y-axis. So it will be negative 40 sine 60 degrees. And finally, we have our 50-pound force, and it will be negative 50 cos 50 degrees. Why? Because the 50 is adjacent to the y-axis. And resolving this one, it will lie on the negative y-axis. That's why we have negative here. Now, summing all this together, we will get y, the summation of all the y to be negative 41.423 Newton. Very good. I hope you are with me. Yes. So as I am solving on the board, try and also be calculating it yourself to verify your answers. To verify your answers. Very good. Now the question demanded of us to calculate for the resultant. Now R equal to root of summation of fx squared plus summation of fy squared. I hope we are familiar with this particular formula. Now our R will be equal to root of the x component, which is 36.076 squared, plus our y component, which is negative 41.423 squared. So solving this, we get our R to be equal to 54.93 Newton. Now after calculating for the R, which is our resultant, that's the magnitude, the question also demanded of us to find the direction of this magnitude, which is the angle theta. So we are going to use the formula tan theta equals summation of fy over summation of fx. So theta, we have tan inverse, because we want theta. So if we want to find theta, we take the tan inverse of this particular fraction. So we have summation of fy over summation of fx. Summation of fy over summation of fx. So substituting the values of summation of fy and fx, we have theta to be equal to tan inverse of, which is our fy given to be, or we had the fy to be negative 41.423, and our fx was 36.076. So theta will be equal to negative 48.945 degrees. Negative 48.945 degrees. So thank you once again for joining Exploit tutorial, and see you again in our